Okay. Hi, everyone. So today I'm presenting from Pivotal Technologies on the topic of enterprise Flutter configuration. What do we mean by that? It's mostly web config because the web is kind of the most complex environment to deploy Flutter at a production scale. If you deploy it in Android and iOS, it's easier to template the values, but I'm going to show the methodology to have the same output for Android, iOS, Mac, Linux, all the native ones, from the more complex web configuration. So, who am I? I'm currently Pivotal Technologies CTO for CTO and CSO, so Chief Security Officer and Chief Technology Officer. Our objective is to make advanced development methodologies more affordable through automation. We're only 3 years old now as a startup. And before that, I was working as a security auditor and a banking auditor and a bank security expert. Some of the technologies we use, because we think that the tech stack is important when you're developing and automating. Mostly Flutter and Dart in front, some HTML and Go for login. CI, we use Bitrise, Tekton, GitHub Action, Bash. Continuous deployment is based on custom stack based on Argo workflow, Argo CD, and a custom deployer. For infrastructure orchestration, it's Terraform Cloud, actually called Vault. Mostly container-based technology, actually only container-based technologies. We don't use any normal node-based monoliths. And within the clusters, it's mostly Istio and Golang or Rust. And we're using the ORI authentication system in open source and even StoreDB for event sourcing. The topic today will be firstly Flutter applicative architecture that we use, then a web production deployment. I'm going to invert a bit the usual process. I'm not going to show the code first. I'm going to show the deployment first, the elements that we use in the deployment in an actual production deployment, and the different elements so that you guys figure out what parts are going to be templated and then go back step by step back to the original code that I'm going to demo and we're going to play with if you have any questions. First, project architecture. So if you want to read, it's mostly about the way we structure the Flutter app. There are default layers that usually you use when you develop a lot of Flutter applications. So you have a data layer that is mostly containing the repository and provider layers that you would find in other domain-driven or domain or clean architecture patterns. And then a domain layer that processes the data. Mostly we're using Block. Well, we're only using Block. And we have the application layer where we host not only Block, but some of the code templating that we're using now that is commonly known as code generation. And then we have a presentation layer that is usually manually coded by our 10 Flutter developers. An example is here to the left. I'm just going to say those so that it makes sense afterwards. It's an example of a production deployment. So those are the environment variables that are passed to the Flutter app for the web application to be deployed. So it has, for example, the index title, which is the name of the app, the description, the color, the splash body, the spinner color, the manifest name, the manifest short name, the manifest background color, theme color, description. Some parameters are not used because they're used across multiple white labels. So some other iteration might be using it, but this one doesn't use it. So I took a bit of a smaller one for it as an example. We're container-based, so that's why you have a repository for the reference and a tag. The value is from a GCS bucket, so Google Cloud Storage reference for the base bucket reference, and the base bucket reference contains all the images, all the translations, and all the other references. And at the bottom, we can see a config map, if the app is in debug mode or not, if the app is in logger mode, and the features that are active for that specific iteration. We're going to go to, oops, is it loading? Yeah, it's loading. So we're going to see it a bit bigger. This is the actual environment in read-only. And we can see the parameters here. I'm going to try and improve this. So here, the screenshot is taken from here. So we can see the same config as before. The features are basically when you do a lot of development and you want to be iterative and deploy rapidly, you need feature flags. So what we can see here as features.json, it means that the selection statistics are enabled, a feature called cancel bet is enabled, a feature called quick bet is enabled, display preferences are enabled, custom sessions are enabled, an advanced open bet page. So basically it's just to say, you can define feature flags, but this is an example of a bit more complex app that can be done that contains such feature flags. And then in your case, if you guys are using Firebase as a backend, we're using it just for the logging, for custom logging from the front-end clients. So you have like the API config for Firebase. So basically it's to log all the message errors, all of the crashes that are happening within our web clients as well, because if you reference that, it will just work in any platform. We're using internationalization with a bucket. So it contains dozens of hundreds of strings in that bucket reference, and all the strings can be translated in the app through that bucket reference. And then here's an example of OAuth config for OAuth 2, which represents the deployment. That changes a lot between environments. So it's the API endpoint for the gRPC services to communicate with the backend. And then sometimes you guys have asked, how do we handle theming in terms of references and images? For advanced theming, we use a theme.json with a reference of the assets in the size 124, 124, 124. The different logos. We sometimes have live animations or directly videos that we host ourselves that are not on YouTube. Oops. So here we go. And otherwise, those other parameters are just to show that this is an actual environment. So we do have Vault that is disabled. We have databases, event store, probes, basically stuff that backend people use. And course headers, because this app is used by gRPC services as well. For the exposed headers and the different methods and the authentication methods. And the autoscaling for HA deployments. So we're going to go back to the references. So who here knows what Brotli is? Brotli is one of the most advanced compression algorithms used for web applications that is supported by most web browsers. So we're using Brotli to serve the main JavaScript elements. It's around 4 to 5 times more optimized than, let's say, directly serving the JavaScript to the clients. And so you could have gzip, but gzip is not the most efficient. Brotli is among the most efficient. So here we're presenting the CI config for packaging your Flutter application in your JavaScript using Brotli. So basically, it's an Nginx image that is packaged to be deployed with Kubernetes. It's listening on 8080. It uses an Nginx root reference and a normal index.html. It references the error values that can be used, the root of a location of the Nginx. Then there's a startup for that Docker image. It replaces the variables that we saw earlier. So the variables that we saw earlier here, the title, etc., they're going to be templated in the index.html. So that method of templating can be used in Android or iOS for static templating via if you have a CI and a CD engine. CI is continuous integration. Think like Jenkins typically, but you have more complex like Tecton or others that are also, or Circle CI that also exist. And then you have, in our case, we call CD, which is continuous deployment, which allows you to template and then deploy. you don't always have to template at the CI level. So here, basically, it's for people that want to replicate the Broadly config, but I'm going to pass through it because it's only if you want to replicate what we did that this is going to be valuable. So broadly, with the Tecton level, when we're packaging the Docker images. The rest of the config is just enabling modules so that Nginx serves it automatically for you. And then once you enable this, you don't have to think about it ever again. The compression is enabled, and whenever a browser is going to get your web page, it's going to be compressed to 5 times smaller than actually if you were to read it in pure text. So yeah, posterity's sake, there's the config we actually use if you want to use something similar.
I'm just wondering, if you broadly, the canvas tick size, how big is it?
I think it's about, well, we can check later. We're going to see it. Remember, if you're using PWAs, be very careful. It's just in a warning, because we had a lot of issues with this. Basically, with PWA, it caches by default the certain files for web, and it uses a service worker in web to serve those files. Sometimes the hashes here can be empty, and where they're empty, it references the previous version of a PWA that might have a version of it. So sometimes we had bugs and we didn't understand what was happening. And here you have to find the empty hash. I think in this version there's no empty hash, but there can be an empty hash. Usually the empty hash is the exact same. So be very careful. If you have bugs and it's referencing like an older version of a PWA, come look in here in the Flutter service worker config. I'm going to show again after where it is, but this is the PWA config for the service worker. I'm going to show it later where exactly it is in the applicative code. But be mindful of PWA for bugs about caching. And then the CD manifest is basically what we use for configurations. So we're using infrastructure as code, which means there's nothing done manually. Absolutely everything is done by machines. And here's the config for the name of a project, the config path for the dev environment, all the theming for dev, and then the internationalization. The values that we saw earlier are passed through here. And then they're passed through the different environments. And the values that we saw. And finally, you have staging and then prod. So developers can modify and just PR this file, and after it's redeployed, it's going to take those configs after it's done. So local makefile. So we're going to go to the makefile demo. So we're going to finally get to some code. Can you guys see? Maybe I'm going to go here. Let me try. So we're within the repository of the app. We have a file called makefile. It's like an older school version of how you would build compiled applications. You would use a makefile. And we're using that technology, or kind of a bit legacy now. People use more yarns or other methods. But because we use a lot of technologies and we remember older school that work well, we still use makefiles for compilations of protobufs and CLI. So we don't write a lot of commands. Instead, we package all of them in code. So for example, when you start a new project, when we do use them, you can just call make build or make upgrade. And the make upgrade would call the code generator to update this version of the code with those templates and template it to and update all the code libraries for which it depends, and then regenerates it. but let's look at it again at the content of a makefile. So those are kind of all the slugs we use to work faster, and they're used everywhere in the company, and it's just an old school method again called makefile, but it does work. So there's the make build, there's the make run web that we're going to be using, the make clean in order to clean all the protobuf and other files generated on the machine, make flush to flush certain elements of configs, install all the tools that you need for this repository. We can try to run the make test to see if a unit test and generated test would pass. We have integrated tests as well that are present. So let's test one of them. Make tests. So it's running all the unit tests and all the widget tests in YAP. The CI does some of the same tests, but essentially, let's try. So that was the objective of this part, to show that the makefile is there to help you. So if you're using local compilation, it can really help. And we are using here a code generator to package our apps. It makes things easier. Instead of writing, let's say, 10 apps and reuse part of the same code base in the apps, they have a parent in terms of code, and the code is code generated for them in the different apps, so that if we modify the generator, it applies to all the children apps. So when you're managing like 20, 50 apps, it's easier, but because we knew that we had to build that way if we wanted to maintain hundreds of microservices for different clients. So it's just us using newer technologies that maybe, or newer methods you haven't heard of, but code generation is just a method to generate code from code and to maintain more efficiently and upgrade more efficiently a lot of code bases. And here, that's kind of the applicative architecture of the app I'm going to show now. So it's a gambling app with an authentication network, and then a white label in terms of applicative services that use all the templating and all the coding, I mean, not the coding, but the libraries and the languages and the currency that are templated. So it's made to look and be adapted in multiple regions. We're going to show the code applicative, but I wanted to explain a bit why. And then it uses gRPC to a core, and the core manages all the security of it. And then it uses third-party proxies in order to manage money, or third parties such as gambling third parties. And then it uses another subsystem for machine learning and analytics in BigQuery and GCP. And the admins use virtual VPNs with identity-aware proxies, requiring an applicative authentication and a Google authentication for accessing those services. So now, it's launching the app. I think it connects to a production version temporarily that was enabled to be connected from a local web engine. So it's connecting and building the config. Come on. Oh, it's launching. So this is an example of an app that uses a bit like here, dynamic loaded references using gRPC web. So those are all real-time values of rates for gambling. So you can bet on cricket, you can bet on tennis, on football, on esports, on golf, on basketball, and like 30 more games in a few weeks. So those apps can be templated to change the way the look and feel of a UI is. For example, here we selected English. Let's go to, let's say, what could be fun? We'll first go to Portuguese. So all the text changed to Portuguese, all the references changed to Portuguese. The references in here, the text, all the details, and then we're gonna change to English to authenticate first. Because I had because I had U2F that was already stored, it authenticated immediately. I didn't even have to use my finger for it to work. We're still running from, I think here we passed to, let me see if it, I think it's going to pass me back to production. Yeah. I don't think we're local anymore, so we're running a copy of the actual production system. So let me check if we force refresh Flutter. So we're doing a hot restart with web. It will reuse the token. And what will the browser do? Meanwhile, while it's restarting, eventually it will do it. We can see here that it can even handle left to right languages such as Arabic. Which one is Arabic? Let's try this one. Nope. First one. So the entire app shifted, even the content of the images and the images orientation shifted for the Arabic Arabic clients, and even the content of the app also switched, so that the experience is fairly seamless and doesn't change that much. And we can even check, for example, at the bottom, if you guys recognize in another language the About app of Flutter. And you can look at, I think that's the only part that's not translated, is the licenses that we have in our source code. That part remains unfortunately in English. We could go a bit further, and let's return in English so that most people here can read. Do I have money in my account? No, unfortunately I don't have any money, so I can't actually bet, but there are features for quick betting. But the part that is interesting is not this one, is if we look for register, which is an endpoint, you can see here that you're going to have a register by player, and it constantly loads data. So this is using gRPC web in order to reference all the real-time rates. As you can see, it's constantly loading data. Here it's moving 50.3.6, 17.81. So this is all the rates on this page being updated, and it actually contains more. If we click, for example, on one of them, you see here it's a ladder of bets that allows you to bet on a betting exchange. So there's multiple values that can be used either for back or lay. But this is not point interesting for us, but that's why there's way more data than the data that you can see here. So there's like 9 instead of 1. So that's why sometimes you will see the data update, otherwise you won't. I think we're in the middle of the day, that's why as well not a lot. Oh, see here, it kind of clicks when it updates. This means that the real-time values are updated by the backend constantly. And it's not using WebSocket, but instead gRPC web streaming technology. So now let's go to the actual config. The app was interesting, but that was to show you can theme, you can change color, you can change strings, you can reverse images, you can contextualize for the region, most apps, and the only thing we can't do yet is, for example, good SEO for Flutter. But a lot of things can be done otherwise to make an app in Flutter do a lot of things, and isn't as bad as it was like 5 years ago to do advanced things. Given that now you have advantage, you can use all the templates that we shown in order to benefit from a real multi-zone, multi-behavior app. So now, how does it look in terms of code? The different code. Can I improve? Maybe. It's not zooming in. So the main Dart of our apps only contains the first loading element to load the app, but mostly in the different layers for the config, we have the custom block provider is somewhat useful to see what are the different contexts that we load. Some of them you're going to remember from the config we referenced. The values loaded by the different configs are loaded here, but in reality, we have this that loads the platforms config, which are the platform options, the theme data, the theme mode, the network assets, the lighting colors, the image assets, the Rive assets, and the translation. And the actual web elements for the local, for them to run, they're templated for the environments, but in the app, they're under web config, and the values are templated by CD. So if you guys remember, we can see the use debug that we saw before, the features that are run locally, the Firebase.js config that is used for the different environments, the internationalization bucket. What?
Zoom is now Zoom.
Oh, the zoom.
Yeah. It's too small.
How do you zoom? It wasn't zooming with view.
You think IntelliJ, right?
Yeah.
Maybe he will find some. This is a shortcut.
Oh, wait. No. So it's
plus.
No.
No.
No. I tried the shortcut. It wasn't. Type increase font. So what's the shortcut?
Double shift.
Yeah. Increase font size. Oh. What's the shortcut for it?
I think there's no shortcut. Do multiple times.
I can't. There's no shortcut for increase font size.
It's increasing, right?
Can you see a bit better?
Maybe turn some of the lights up.
Oh. I don't know how to turn off the lights. But basically, the configs here that you guys see are the same as before. They're just used for the local templates for them to run. And oh, that should be a bit better. So what would be the elements that you guys want to see in terms of code base? If you have questions about the code, now that we saw a bit of the elements of config, how it's, go ahead.
Are you running Flutter apps as well through Flutter?
I didn't.
Like Flutter gaming? Because I was just checking out the site and there's background, all of these apps.
No, that's all Flutter.
Yeah, so you built like a rooms for them, and you're running through.
No, it's part of the backend. So if we relaunch, the app is still here, and you can launch the card and play card games. Or we're also adding other types of things, but Flutter can encapsulate the iframe like normal apps. So you can do anything you want now in Flutter. The only limitation would be fragment with, how is it called? Shader technology has a few limitations. So if you're someone like Unity and you want to build a pure game engine, that wouldn't work. you would need advanced technologies like Web GPU. But if you're doing any normal website now, it can probably be done entirely in Flutter instead of being done in regular web technologies.
3D support is coming.
Yes, but it's not there yet. I only talk about what's currently present. Because we've been using it for 5 years, so we know about all the limitations and all the problems that come along. What? Play one of the card games? We can try, but it's going to say that I don't have any money.
So you use WebView for this part?
Yeah, it's encapsulated in a web view within an iframe. So you can bet on stuff like this if you want, but it's not the objective. The objective is to talk about the technical capabilities, but it's not on the gambling itself. If you want, you could bet on, I don't know.
Sorry, I'm interested in the Python example. Is it dynamics involved?
Dynamic export.
Animation, you said, is it not an animated or?
No, this is all Flutter. Every single element that you see here is Flutter. In the bet, the match bet, the reactiveness, the sidebar. You're talking about the web view, the iframe?
Normally in a back game, you go through a portal and you play at the table with animation. Sorry, I haven't checked. I assumed that because you were offering both on the site.
No, but this is the app that I showed that we can reload locally and for which you can technically bet. But right now, if you try to bet, for example, let's try betting. It's just going to say you want to put the money here, and it's going to refuse placing the bet because the wallet has 0, and the app is configured not to let you bet when you don't have any money. So, but that's not really the point, right? The point was to understand the gRPC web technology and the templating that allows you to make like an app like this. Let's say one in Indonesia, one in India, one in Germany, and they all use the same core that is in Frankfurt. And so you can do anything you like. So we're branding this as a gambling platform that allows you to do pretty much any type of gambling on any platform, and you can have this exact same rendering that we did here, but I would have to tweak it a bit to render on Android, iOS, Mac, Linux, and other platforms that are native with the exact same rendering. I forgot to show. Yeah.
How do you actually do the more complex UI? I guess.
So let's
Because
go.
like a core platform, the core that's running on two different platforms, often you get like the edge cases where we can't actually get the rendering we want, or UX we want, or
So
preciseness, like the.
So we do.
This is like pretty simple and straightforward.
So you can do. We have a super small mobile rendering that is landscape and portrait. Then we have tablet, and then we have desktop, and then we have super large screen. By covering each of the point bases, you can have a similar stretch that you would have in native Android. The behavior can be run and have something very similar to the point where it's hard to tell the difference. But here,
I guess I was wondering, just give an example, the gaming feature we have on the app, like shake your phone, and you're going to get a random hit or something that's going to appear in the app.
so
Kind of easy to do native or on Android and on iOS.
So Flutter allows you to run the core of Flutter and then use platform channels to interact with native Android or native iOS or native web or native Windows or Mac or Linux. So there's a native code base that allows you to run a sidecar in the specific technology, but it's also to be able to run, let's say, a real native Android app and then use some parts in Flutter that would be shared. And some people, for some projects, for example, we're doing this, they have a native Android and iOS, and we're merging with a Flutter, calling both the others, but it's almost always a rewrite because there's no need most of the time to share code base with Android and iOS. If the app's already done, there's no real point. But if they want more features and they want a complete rewrite, then we do a complete rewrite. Then we add just the functionalities needed, like you mentioned. The native limitations are calling the native Android code or the native platform code. So that was pretty much the base of the issue. Is you want to use Flutter. You want to be able to use Flutter for in web is a bit more complex than iOS and Android. If you're using iOS and Android, you have to use the templating like I showed. You pass the values that you want to change between an environment and another, and then you make templates resolve it for your different environments. You can use Dart define as well in order to solve this. But in our case, it was a bit more complex, so we need like dynamic bucket references, dynamic images, dynamic internationalization strings. So this is an example of a bit more complex use case where you can render still efficiently your Flutter code, but load a lot of things dynamically, notably strings and images. gRPC Web and gRPC allows you to run 5 to 6 times faster than REST. So our implementation is faster than most gambling websites. The core engine is in India here. And so everything was doing back and forth to India during the demo. And gRPC Web works well because we've contributed for it to work better with Flutter. And also, finally, if you're doing very large-scale projects that are using newer technologies such as gRPC, gRPC Web, or banking or gambling, and you have a very complex use case, we can be contacted for help. Thanks.
Anyone have some question?
The performance, such as the loading times. Right now, I think it's using either or. So if you're using mobile, it's using Canvas, and then if you're using web, it's using HTML render. So this is the current score for this app. So what were you looking for? Total blocking time. So for reference, this is in India. So the back and forth here is 400 milliseconds. If you use the app in India, it's 100 milliseconds. So it's faster than most apps. But that's not because of Flutter, that's because of gRPC and event sourcing. So we're using Service Worker. So if you reload the page, a client, let's say, reloads the page, like happening here, the core is already present and in the cache of the page through the Service Worker. And so it doesn't reload all that content. It serves that content immediately. So let's say we're doing typical network here, and I force refresh the app. You see everything is discached for Service Worker. On the right, can you see discache Service Worker, discache Service Worker, discache Service Worker? So all those references are not reloaded second time around. So that's what makes it faster afterwards. But the first time you have to pay for it. The first time you have to pay for storing it for the client. So that's one of the things I said we would talk about afterwards. So let's look at it. So the main .js is supposed to be the biggest file. What? So it's loading the content via HTTP3 here, and using Envoy, and the response, the content is a JavaScript here. And if we look It's application JavaScript. And where's the compression? Content encoding you see here, BR. So that means broadly. The content and the JavaScript served, instead of being the real non-encoded broadly, it's the compressed broadly that is being served to you. So we can see it here. And the PWA, if you're looking for PWA configs, there, sorry. So PWA here is the name that we saw earlier that were templated. So the name, the short name, the description, and then you have images so that you can click on it to be stored on, let's say, here you can see this. If you click on that, it would install the app on Android or iOS from a web app. So this allows you to not do a native app and instead use a PWA, which means progressive web app, to have the same capabilities without having to have Android and iOS on the App Store. A lot of gambling want this because if you go on Android and iOS, they're technically not allowed. So they prefer a lot PWA. So PWA was used a lot by gambling technologies or music. Music didn't need that, but gambling had that problem for a while. And now it's being, they're heavily applying taxes on it, but it's being legitimized in India, I think, and in a few other countries where they apply more than 30% tax on all winnings, and then not considering it to be legal anymore. And the situation is changing a bit from that point of view because people are playing anyway, whether it's taxed or not. So, and I think Google changed a bit their policy towards it as well. But our objective was not to serve the gambling domain, it's a domain that needs heavy security, heavy performance, not too bad UI UX, and yeah, that's what attracted us for that type of client. Yeah, and the service worker can be seen here, and it was registered 5 minutes ago. Yeah, that's about it. Any other question?
One more. Actually, I think in your three question was, my question was, why focusing on PWA instead of like Android or iOS app? I guess that's very fast.
Is in order not to need app stores, correct? But specifically for this use case that was gambling. But for us, the objective was to be able to provide an easy experience just by having a QR code. So because you can do that technically in Android and iOS, but there's a few more steps, whereas in web it's immediate. So we've been focusing on that part, and because from our point of view, you can do Android and iOS, but PWA serves most use cases and prevents you from having them. If you don't need the native integration, there's no real reason to do a native app anymore. It's just if you need, like, for example, the shaking of your phone, the payment library that you need for a payment system. Those are the only use cases for which you need native. If you don't need native, don't use native. It works, it's just not great. The PWAs work on iOS as well right now. Yeah, and I think that's it.
So that's a 15-minute break.